Here's another example. So we're looking at a randomized block design, has a treatment variable with 6 treatment levels and a blocking variable with 10 blocks. Using this information and alpha equals 0.05, complete the following table and reach a conclusion about the null hypothesis. Okay, so we will get the total sum of the squares for the total variation. If we add the treatment sum of squares and the block sum of squares and the error, we add those up, we get 17,319.39. The corresponding degrees of freedom for the treatments. Now there's 6 treatment levels, so we would have, so that would be 6, subtract 1 would be 5, because there's 6 columns there. Then for the blocks, we have 10 blocks, so that would be n minus 1, so that'll be 10 minus 1 is 9. Then for the error, you just multiply those two. 5 times 9 gives us 45. The mean square for the treatment, it's calculated if you take 2,477.53 divided by 5. That'll give you the mean square error, 506. And then for the blocks, same thing, 3,180.48 divided by 9. It's going to be 353.387. And check and see if you get the same. That's a 7 at the end there. And then same thing, take the sum of the squares for the error, divide by 45. Check and see if you get 259.142. Okay, for the observed F values, for the observed F, you take the treatment, the mean square for the treatments, 495.506, and divide by the mean square error, 259.142. And that will give you the F value for the treatments. Should get that. Then for the blocks, the F value for the blocks, take 353.387 and divide always by the mean square error, so that's 259.142, and should get 1.364. All right, and we now need our 2 different critical values. So we'll do for the treatments. So for the treatment, we're going to have 6 treatment levels, and the critical value, from the table, we'll use alpha at 0.05, and then we want 5 degrees of freedom, right, and 45. That's for the treatment variable, and then we have the blocking variable. So the blocking variable will be 0.05 as well, but this time 9 degrees of freedom with 45. So let's go to the table, see if we can get those values. So we will look up 5, alpha is 0.05, and then we want column 5. Now we don't have a 45, so I had already said we should use a 40. We'll use a 40 for both cases because we do not have a 45 and we don't want to round up all the way to 60. So we'll use 40, and that is 2.45 for the treatment. And then for the blocks, we want 9, corresponding to 40 again, so that'll be 2.12. Okay, so let's take those values back. So that's going to be equal to 0.05, 5, and 40, and 2.45. And this will be table value 0.05, 9, and 40. That gave us a 2.12. And so we can now look. The F for the treatments, which is 1.912, is greater than 2.45, or I guess I can keep the notation. We'll keep the notations consistent. So is the observed F greater than the table F? And it's not, right? Because 1.92 is not greater than 2.45. Therefore, We do not reject. Do not reject. And here is our observed value greater than our table value. So 1.364 is not greater than 2.12. Same result. Do not reject. So in this case, we do not reject, and the test is not statistically significant at the 5% level.